Okay, hi class. So we're back, and this is part 2 of 7.1. So we're still back on 7.1. Just my computer was having a conniption fit. It was making stuff look really weird, like right here. But we're back. I restarted. So let's go ahead and finish this section, and I'll post this as part 2 of 7.1. So let's just get some more work. Let's verify some of these identities. So for instance, tan theta cosine theta equals sine theta. So again, the tips that I wrote up here were you want to start on one side only, and you want to express terms of everything in terms of sine and cosine. So here I think I'm going to work again on the left hand side because it's way more complicated, right? I have tan theta cosine theta. There's nothing I can really do on the right side. So if I write the left side, I'm going to work on the left hand side, and I'm going to express everything in terms of sine and cosine. So cosine is already a cosine, but if I express tan theta as sine theta over cosine theta, and I multiply it by cosine theta, well, do you see what happened? Pretty easy, right? The cosine thetas cancel out because it's like over 1, and then we get just sine theta. Okay, and guess what? That's the right hand side. So we're done. Cool. So that is how that works. That one's a little easy, but the idea is the same. I only worked on one side. I just rewrote everything in terms of sine and cosine, and that ended up with the right hand side, which is what I wanted to show. So let's do the same thing over here. It's going to be a little more complicated here, but again, it looks like probably the easiest thing to do on this one would be to work on maybe the left hand side, because it looks like I can FOIL here. So I'm going to work on the left hand side, and if I FOIL, you get that times that, and you get that times that, and that times that. I'm left with 1 plus sine negative x plus sine x plus, now let me actually do this first. Sine of negative x, what is that? Well, sine of negative x, remember we talked about sine was odd. And so what did odd mean? That odd identity? Well, if I have sine of negative x, I can replace it with negative sine of positive x. And so the negative doesn't matter. So let me just rewrite that right now as negative sine of positive x, like that. So actually, to make it a little easier, let me rewrite that all. So what I actually have before I even start multiplying is 1 plus sine x times 1. It's going to be minus sine positive x. So that's just using the odd identity of cosine. So sine is odd. And then what I can do is just go ahead and now do the FOIL. So if I do that times that, that times that, that times that, and that times that. If I do the FOIL now, I'll get 1 minus sine x plus sine x minus sine squared x. And you see that's nice because these are like terms now, and they're opposite signs, so they cancel out. No pun intended about sine being sines. Anyways, bad joke. Okay, so now we have 1 minus sine squared. Okay. Now, what do we want to get to? We want to get to cosine squared x. Well, this actually does equal cosine squared x. And this comes from a Pythagorean identity. Okay, remember that's back up here. Cosine squared is equal to 1 minus sine squared. So here on our problem, I saw 1 minus sine squared pop up, and I know that that's equal to cosine squared, and that comes from the Pythagorean identity. And so there you go. And so we got to, from the left side, we were able to get to what we want. We were able to get to cosine squared. And so we're done. So we verified the identity. Okay, so that one was a great problem because I had to use the odd identity. I had to do some algebra, some FOILing, combining like terms, and then I had to use the Pythagorean identity, which I knew as well. Okay, so let's move on. So let's try this one. This one has a fraction here. Again, it looks like probably the more complicated side is the left-hand side. There's not a whole lot I can do on the right side except maybe express that as 1 minus cosine squared, but it's hard to see why that would become the left-hand side. Well, let's just go ahead and follow our nose here. So I'm going to start on the left-hand side. And I think the good thing to do would be, again, express these guys in terms of sines and cosines. Another way you could do this is that there's a little algebra trick. When you have one thing on the bottom and two things on the top, two terms, you can just go ahead and divide it into both. So why don't we do that? So this is more of an algebra idea. So what I can do is I can split that left side up into secant squared x over secant squared x minus 1 over secant squared x. So that's pretty cool. That's just a rule from algebra. So if you have one divisor with two terms on top, you can split the fraction up with like this. It's like sort of like doing the opposite of getting a common denominator. They already had a common denominator and I split it up. So anyways, what happens here? Well, secant over secant, that just becomes 1. And 1 over secant, well, that might be a little hard to think about, but let's remember that secant squared x is defined as 1 over cosine squared x. So if I have 1 over that, that's 1 over, and so this thing just flips up, and so it equals cosine squared x. So this just becomes 1 minus cosine squared x. Okay, so I have 1 minus cosine squared x on the left side. And what do I want to get? Oh, sorry, I should have been calling them thetas. That's my fault. Probably did that up here too. Okay, good. I apologize. So thetas, these are all thetas. So 1 minus cosine squared. Okay, so now the question is, does that equal sine squared? You betcha, that does equal sine squared. And again, why does that happen? Again, that's from the Pythagorean identity. So the Pythagorean identity, like I said, is the grandmama, the grandpapa of all identities. It comes back a lot. Right here, we can solve for sine squared here, and sine squared would equal 1 minus cosine squared x. So that's why 1 minus cosine is equal to sine squared. And guess what? That's the right side. So we're done. Right hand side. So we just showed that the left side does equal the right side. Okay? Alright. Alright, and the last couple we want to do is, last identity I should say we want to do, is again more of a foiling. So let's go ahead and try this one real quick. So we're going to go ahead and FOIL this times this, etc. So work on the left hand side. So we get 1 plus cotangent squared x minus cosine squared x minus cosine squared x times cotangent squared x. Okay? Alright. And I think the next thing I would want to do is I would want to write everything in terms of cosines and sines. So here we'd have 1 plus cosine squared x over sine squared x minus, this already is just a cosine squared x, but I'll put it over 1 to help us, because we're probably going to get a common denominator. So minus cosine squared x times cosine squared x over sine squared x. Okay. And just a second. Make sure my audio is working. Okay, and so the next thing we want to do is we want to get a common denominator. But just a second, my pen is freezing again. Just a second. Okay, thanks. Thanks for being patient. My computer's having a hard time here, but we're trying to make it through the rest of the semester. Only 7 more videos, so I really don't have to buy a new computer. And this is the school's computer anyways, but it's like 5 years old. But anyways, okay, so here what can we do? Well, again, I think probably the best thing to do would be to get a common denominator. So I'm going to multiply everything that doesn't have a sine squared on the bottom. I'm going to multiply by, sine squared over sine squared x. Same thing here. We're going to multiply this by sine squared x over sine squared x. Okay, so what does that give me? Well, so I get sine squared x plus cosine squared x minus cosine squared x sine squared x minus cosine squared x times cosine squared x. Okay. All right. So, and this is all over sine squared x. All right. So the cool thing is that this thing right here is equal to 1. That's the Pythagorean identity. So sine squared plus cosine squared is equal to 1. And so what I have now is I have 1 minus oh, you know what? Made a little mistake right here. That's a cotangent squared. Sorry. A cotangent squared. So that's a cotangent squared. Okay, that was what's throwing me off. No, that's a cosine squared. Okay, hold on. I think I have a better way to do this. I apologize. I'm also running out of room anyways, so that wasn't going to work. Why don't I do that common denominator stuff first? So sorry about that. But so here I think what I'm going to do first is, yeah, that's what I'm going to do. So left hand side, before I even do any multiplying, let me take a look at this. So I have the 1 plus cotangent squared x. Let's rewrite that as 1 plus cosine squared x over sine squared x. And I want to stress that it's not there's not one right way to do these. Sometimes there's multiple ways, and sometimes one way is just way harder than the other way. So it's more of an art than a science in that you just kind of have to just play around with it. And if you go one way and you find a dead end, that's okay. We just go back and we'll try again. Some people really love this stuff. Like this is their favorite section of pre-calculus, solving, verifying these identities. Those are usually the more playful, curious, creative types. Those who just want a straight answer and don't want any chance for error, they might have a lot tougher time with this one section. Okay, anyways, here I'm going to multiply, get a common denominator. So I'm going to multiply it by sine squared x over sine squared x. And that's what leaves me with, now I have sine squared x plus cosine squared x over sine squared x. There you go. That is what I want. And now let's work on this. This 1 minus cosine squared, okay, guess what? That's another Pythagorean identity. That's equal to sine squared x. So that's from the Pythagorean identity. Okay? So one thing we did is we just, so on this side we just did some algebra. Oh, and guess what this also equals? This equals 1 over sine squared x. Okay? Again, why? Because this is the Pythagorean identity. This equals 1. Alright, so now we have this parentheses here is just equal to sine squared. So now we'll have sine squared x times excuse me times 1 over sine squared x. All right. That's what we have on the left hand side now. And so now those just cancel out. And we're left with 1, which was the right hand side. Cool. All right, so that was a fun one, a little more indirect. We had to do some work before we did the multiplying, but that's okay. Okay, so now what we want to do is this is a little preview of coming attractions. We're going to learn how to solve. The whole reason we learn these identities is, I mean, they are fun and they do reinforce the identities that we learn. But what's really important is that they help us solve stuff that's solve equations. So I want here, the last two that we do, I wanted to solve these equations. So we actually are going to be solving. We're not going to be proving identity. So we do want to find out an answer. And this first case that we're going to learn a lot more later on in the chapter, but it's called by factoring. And by factoring, check it out. This thing actually can be factored. This is a quadratic. It's cosine squared plus cosine minus 1. So think of this like if you just call this u in your mind, okay, then this would be like u squared, 2u squared, okay. So this thing becomes like 2u squared plus u minus 1. And the way that would factor, this all equals 0. So again, just to make it clear, I let u equal that middle term, cosine theta. And so now this factors is 2u, u, what's that going to be? The minus 1 has to go here, plus 1 here. So that's 2u squared plus 2u minus u. Yep, okay. And so that gives me two answers. It gives me 2u minus 1 equals 0, or u plus 1 equals 0, which tells me u is equal to half, or u is equal to negative 1. Now what's cool about that is that what did we say u was? Well, u was cosine theta. So we have two answers now. So the first answer is u equals 1/2, which means cosine theta equals 1/2. Okay, and our second answer is going to be this one. Cosine theta equals negative 1. And then here is where we just have to simply use our unit circle knowledge. Now, the algebra that we're doing, if we want to solve this, is that we could take cosine inverse of both sides. So the algebraic answer would be that theta is equal to cosine inverse of 1/2. And we have to find that. We can't use a calculator because I want the exact answers, but we could also just use the unit circle. We don't have to do this step. We could just say, okay, this question is asking us for what angle makes cosine produce half? And on the unit circle, half for cosine is going to be the bigger angle in the first quadrant right here. So that's pi over 3. But it's also going to be down here as well, which will be 2 pi minus pi over 3. So that's 5 pi over 3. And so our answer is going to be pi over 3 and 5 pi over 3 for that part. Okay. Now, the other answer, when does cosine theta equal negative 1? Well, again, you could take cosine inverse of both sides, but what really matters is that we know that down here, over here I should say, cosine is negative 1. That only occurs once in the unit circle. So negative 1's right here, and what angle is that? Well, that's pi. And so this tells me here that theta is equal to pi. Now I could get more answers, right? I could, add, remember cosine and sine have period 2 pi. So this could give us this could give us more answers, like I could add 2 pi to this. Write that in green maybe. Could add 2 pi. Okay, but let's look at the problem. The problem was asking us only to stay in the unit circle. So because I only stayed in the unit circle, that means I can just say no. I only want these answers. So there's only 3 answers here. So I would just write all the answers as 1, 2, 3. So we have 3 answers here. Okay. Last problem we want to do is the same thing. We want to factor, and we only want answers in the unit circle, in the first rotation of the unit circle. So now we just go ahead and take a look at this. So we try to do this one. So again, if we let u equal cosine theta, that means that u squared is equal to cosine squared of theta. So that means here that what we actually have is 4u squared minus 1 is equal to 0. Now that factors, that's called the difference of two squares, and so that's 2u plus 1, 2u minus 1 equals 0. And that tells me I get two answers. 2u plus 1 equals 0, or 2u minus 1 equals 0. So again, that's the difference of two squares. And so I get one answer is u is equal to negative 1/2, or I get one answer is equal to u is equal to half. And then I replace u with cosine theta, and so my first set of answers I should say, is going to come from cosine theta equals negative 1/2, and my second set of answers is going to come from cosine theta is equal to positive half. And again, we just have to know our unit circle. If I'm looking for 1/2, well, that's right here, and right here we have that answer over here, and so that tells me theta is equal to pi over 3 and 5 pi over 3. Okay, and the other one, oh shoot, that was the wrong place. It goes right here. Theta is pi over 3 and 5 pi over 3. Okay, now for negative half, where's that going to happen? I'll do that in red over here. For negative half, it's just going to be the other pi over 3. So it has to be right here, because x is negative right here. So it's going to be 2 pi over 3. And it's also going to be the one down here, and that's 4 pi over 3. So we get our, in this case, 4 answers. We get 2 pi over 3, 4 pi over 3, and pi over 3 and 5 pi over 3. So those are our answers there. All right, and that's all that we get. Okay, thanks everyone for. I know the video got split up into 2 parts, but that's what we had to do. Thanks for your patience, and I'll catch you on the next video.